I need you guys to copy down lesson 7.3, more multiplication properties of exponents. Anything today that I highlight in black or box in black, you guys need to copy down. So this 7.3, more multiplication properties of exponents. Our objectives are to raise a power to a power, and to raise a product to a power. We're going to go over each. Let's write down 3 squared. 3 squared. Now, what we're learning today, we all know that 3 squared is 3 times 3, which is 9, right? Right. Okay. What we're learning today is what happens when you square an exponent. So what happens if we took this 3 squared, we put parentheses around it, and we squared the whole thing? Technically, what this is saying is it's saying let's take whatever the base is, which is now 3 squared, and we multiply that by itself. So this is the same as 3 squared times 3 squared. Okay? If you square something that's already squared, you just take it and you multiply it by itself. Hold on, I'll get there, Carlos. I know you're jumping ahead. Give me a second. Let's take 3 squared to the 3rd power. We'll get there. 3 squared to the 3rd power. What is that? Roy? 3 squared times 3 squared times 3 squared. Excellent. What about 3 squared to the 4th power? Tessa?
3 squared times 3 squared times 3 squared times 3 squared.
Excellent. Thank you for saying all of them. I would have given up. Okay? Not lying, because I'm tired from today. Okay? Now, what we're going to do is we're going to find out what each of these are equal to, and then we're going to look for a pattern. Okay? Look for a pattern with where we started and where we ended up. The first one, that 3 squared times 3 squared, what is this equal to? Nicole? 81. Wow, that was good. But in terms of 3. In terms of 3. You're absolutely right, but in terms of 3. 3 to the what?
3 to the 4th.
Excellent. I was not prepared for you to say 81. That is awesome. Okay? 3 to the 4th. How'd you get that, Nicole?
Because the base is the same and we just add the exponents.
Very good. When we multiply 2 values where the bases are the same, we can just add their exponents. What's the second one going to be? I'm going to ask a Zoomer. Gabby Piedra.
It would be 3 to the 6th.
Excellent. And Angelina in here, in class. What's the last one?
3 to the 8th.
Very good. Now, don't look at the pattern going down. Look at the pattern from starting here and getting here. Starting here and getting here. Starting here and getting here. Does anyone see a pattern there? Anderson, what do you see?
It's multiplying by 2. So it's like increasing by 2. Or, well, yeah, you know what I'm trying to say.
Okay, but just use the numbers that we have up here. Carlos?
What I'm noticing is that you take away the exponent of 2 in the parentheses.
Okay. Roy?
It's just multiplying 4 and 2, or 2 and 2, 3 and 2, 4 and 2.
That's exactly it, okay? All you do when you raise an exponent to a power is you take them and you multiply them together. What's 2 times 2? Wasn't our answer 3 to the 4th? What's 2 times 3? Wasn't our answer 3 to the 6th? Are our minds blown yet? What's 2 times 4? Wasn't our answer 3 to the 8th? That is all we're learning today. But it gets a little messy, okay? We're going to get our hands a little dirty today, okay? We're going to get our hands a little dirty today. But in the beginning, it's this simple, okay? but we're gonna throw in some fractions, some weird stuff. But we'll survive. We'll get through it, okay? Now, keep in mind, you want to pay attention today because we do have the GIM kit at the end for half off your homework, okay? Not a free homework pass, but you only have to do half of the homework, okay? All right, let's do it. I need you guys to copy down what I'm going to box in black. The only thing I want you writing down is this portion up here and these 3 lines. Anything outside those 2 boxes, you can ignore. Anything outside those 2 boxes, you can ignore. We literally were on that page for like 4 minutes, Rioni. Okay, so n to the 4th raised to the 7th. N to the 4th raised to the 7th. Anything I box, guys, I want you copied now, and you can basically ignore the rest of it, okay? N to the 4th raised to the 7th. Based on the last slide and the 2 problems we did before, what is this going to be? N to the 28th. We're going to do n to the 4th times 7, which becomes n to the 28. And we call it a day. We're done. Okay?
So much for a lot of writing. I was actually stressed.
We'll get there.
But then again,
Don't worry. Don't worry. If you already got that one copied down, start copying down the next one. X to the 2/3 raised to the 1/2. You know the answer?
No, I was wondering, make the denominator the same.
Mm-mm.
Even.
We make the denominator the same when we add them, right?
Oh.
Now we're multiplying them, so it's going to be a little bit different. So we'll do this one together, but then you guys get to try the next one on your own, okay? X to the 2/3 raised to the 1/2. What do you guys think this is? Anderson?
Simplify is x to the 1/3.
Very good. How'd you get that?
Multiply 2 times 1/2, which gives you x to the 2/6, and then you simplify that, is x to the 1/3.
Good. So what we write this as is x to the 2/3. We multiply that exponent by the exponent outside the parentheses, okay? Maya, what's up?
I was gonna say the answer.
Yep. What is the answer, Maya?
We can cross cancel both of the 2's, which make 1's, so that's x to the 1/3.
Excellent. That's exactly what Anderson said. Perfect. So we're in agreement. X to the 1/3. You could have canceled out the 2's, or when we multiply fractions, how do we multiply them, Elijah? How do we multiply fractions? You don't know? We multiply them straight across, okay? So this 2 gets multiplied by the 1, and the 3 gets multiplied by the 2. Just like this. See the arrows? So this would be 2/6, which eventually simplifies to 1/3. Okay? This is our final answer. We all got that down? Okay. Just copy down A and C. And I want you guys to try them on your own. A and C. All right, Elijah, coming back to you. For A, what do you think we're going to get?
B
Very good. P to the 20th. How'd you get that?
I got that by multiplying the 5 and 4.
Excellent. So we just do P to the 4, or to the 5 times 4, which is P to the 20th. Excellent. Now for the tricky one. Who thinks they got C? Giancarlo, what'd you get?
P to the 1/8.
Nicole, did you get the same thing? Very good. It's P to the 1/8. We multiply the 1s, we multiply the 2 and the 4, and we get 1/8. So it's P to the 1/8. Excellent. Are there any questions so far on any of these examples? All right, trick question. Why don't we need to find a common denominator when we're multiplying fractions? Giancarlo?
That's only adding.
What's that?
That's only adding.
It's only when we're adding or subtracting. Very good, okay? You only need to find a common denominator for fractions when you're adding or subtracting them. When you're multiplying, you can just say, whatever, and just multiply straight across, okay? All right, now it's gonna get a little tricky. Make sure you're paying attention. We're gonna have multiple variables, okay? So we have y to the 3rd times y to the 5/2 to the negative 2nd power. Oh gosh, is right. Okay, so I'm going to walk you through the first one, and then I want you guys trying like 2 on your own, okay? Whatever's raised to an exponent, you have to identify what the base is. In this case, our exponent outside the parentheses is -2, right? What's the base for the exponent -2? Ashton? Very good. Y to the 5/2. This is our base. Why is y to the 3rd not part of our base? Roy? It's outside the parentheses. Okay, do you guys all see that? If it's outside the parentheses, it's not part of our base. So Alan, whenever we rewrite this, y to the 3rd is just going to chill. Okay, so we're going to just rewrite y to the 3rd by itself, outside. It's just chilling. It's just hanging out there. It's not involved right now. Alan, what do I do with the other part? Okay, but what do you mean by that? You don't know? Nicole, what do I do?
You multiply -2 times 5.
Beautiful. Beautiful. So I'm going to take y to the 5/2. Remember, we multiply these two numbers. So 5/2 times -2. Now, 5/2 times -2. We need to rewrite the -2 as a fraction. How can we do that without changing the actual value of the fraction? Tessa? Add 1 where? No. On the bottom. Because we want to divide by 1, which would keep it the same. Okay? So this is going to be y to the 3rd. It's just chilling. It's going to stay chilling for a while. Okay? Times y to the 5/2 times -2/1. Now, does anyone see anything that would make this a little bit easier before we multiply? Roy? The 2's. Do you see how one's in the top and one's in the bottom? Maya already told us we can cancel those, right? So these become 1's. So now our exponent is just y to the cubed, or y cubed, which is just chilling. It's still there. Don't forget about it. But now what's our exponent for the second value of y? Nicole? Very good. Y to the -5. Wow, that was a lot, but we're not done. We have y to the 3rd times y to the -5. Who can tell me what we do next? Tessa?
You're gonna keep the base and then subtract 5 minus 3.
Not 5 minus 3.
No, 5. Wait. You're gonna.
Giancarlo, help her out.
Multiply.
Nope. You were right. Carlos?
You add -5 to 3
Very good. You add -5 to 3, or you do 3 minus 5. But don't do 5 minus 3, okay? Because that will give you a positive number. So this is going to be y to the third minus 5, or plus -5. Gianni, what do I get here?
Y equals -15?
Nope.
Okay, bye.
Hi, what's up?
No?
For what?
Photos.
Oh, no, I'm not dressed up.
Huh?
I'm not dressed up.
No, I'm a student.
Oh, go for it.
Are there any students who are dressed down? No?
Maya is, Victoria is, but if they want to get pictured.
Yeah, I won't force you if you're not comfortable. Okay, bye.
Bye. Okay, we do not get -15 here. We just add these two together. Roy, what should I get? -2. And guys, we're still not done. Why are we not done, Alan?
There's a negative exponent, so you have to put it in a fraction.
Love it. We have to change it to the denominator. So this is going to be 1 over y squared. Okay? Now, I want you guys to take a minute and just appreciate how pretty this was. We went from this weird convoluted equation thingy to this. Isn't that so nice and pretty and awesome? X squared times x to the 6th raised to the -4. I want you guys trying this one first. Go ahead and copy down A. You guys, what's just gonna chill for a little while? Ashton. X squared. X squared is just gonna chill. Why is that the part that's gonna chill? It's non-parentheses, okay? So it's just gonna hang out for a little while. What do we need to do with the other part? Alan? Multiply what? The -4 and the 6. So this is gonna be x to the 6th times -4. Oops. -4. Who's good with those times tables? What's 6 times -4? Anderson? -24. So this is x squared times x to the -24. What do I do next? Ashton?
I subtracted 2 minus 24.
Okay, and what'd you get, Nicole? Good. Why can't this be our answer? Tessa? The exponent is negative. It needs to be what? Positive, okay? Janessa, how can I rewrite this so that we have a simplified answer? Say that one more time.
X to the power of 22.
Good. 1 over x to the 22nd power. How many of you guys got that without me walking you through it? Good.
I've gotten there, but it's too small.
You were too slow? Okay. I want you guys to do one more. Don't be intimidated by the fraction, but I want you to do B. All right. Did anyone get W cubed? Walk me through it, Giancarlo.
So what I did first is that I multiplied the 5/3 and 3, and I put a denominator underneath the 3.
Okay.
I get 1.
Okay, so hold on. What's chilling, guys? W to the negative second. And then I agree with Giancarlo. He said we're going to multiply the 3 with the 5/3, which would be 5/3 times 3/1. Completely agree. What happens next, Giancarlo?
And then I get 15/3.
Okay. W to the negative 2 times W to the 15/3. Okay.
And then I get, I divide it and I get negative, or W to negative, W negative 2 times W to the fifth.
Mm-hmm.
And I get W to the third.
Good. W to the negative 2 plus 5, which is W to the third. There's one area, Giancarlo did this perfectly, 100% right. There's one thing that he could have done to save him a little bit of time. What is it, Roy? Cancel out the 3's. Do you see how you multiplied 5 times 3 and 3 times 1 over here?
Yeah.
You could have just canceled out these 3's. And then you would have gotten W to the 5/1, which is just W to the 5th. You would have bypassed this step and gone right to here. Do you see that? Okay? It's just a little trick. If you do it your way and you're consistent about it, you're going to get the same answer. No problem. Okay? But there's just a little trick. You can cancel out those 3's. It makes it a little bit easier. Okay? Why didn't we move W cubed to the denominator? Ashton?
Because it's positive.
It's a positive exponent. We only move the ones that are negative, okay? We leave the ones that are positive where they're at and we call it a day, all right? Okay, guys, we're almost there. Actually, are we there? We're almost there. I need you to copy down this problem. And yes, I know it looks intimidating, but it's not. It's not. Okay.
Is that negative? 2/3?
Yes, that's a negative 2/3. So n to the 1/2 raised to the 10th power times 4mn to the negative 2/3, all raised to the 3rd power. This first part we've seen before, right? N to the 1/2 raised to the 10th. What do we do there with the first part? We just multiply those two numbers. We multiply the 1/2 and we multiply the 10, okay? So that's the same. We've done that, we've seen that, we just did a bunch of problems like that. So let's rewrite that as n to the 1/2 times 10/1. Now, this second part, okay? This one looks different. Why is this one different? Carlos?
I want to say 2 variables.
Yep.
but I might mess it
No,
up.
you're 100% right. There's 2 variables. There's also a number in there, right? So there's more than one thing other than just a variable and an exponent. So what we do is we put 1s over everything that doesn't have an exponent, okay?
Wait, why'd you put it with M?
Because the m doesn't have an exponent. The n does have an exponent, though.
The negative 2/3 is attached to the end.
That's not a minus 2/3. That's a negative 2/3 as an exponent. Yeah.
Wait, then why'd you put it over 4?
Or you could exponent.
1 is an exponent. So like 4 to the first power is just 4. M to the first power is just m, okay? Whenever you have just a single number or a letter, you can just put an exponent of 1. It won't change it at all, okay? We're going to take this 3 and we multiply it by every exponent inside of here. So watch what we're gonna get. We're gonna get 4 to the third, m to the third, n to the negative 2 over 3 times 3. We multiply that exponent that was outside to every exponent on the inside. Not just the 2 over 3, but to every single one. What did that look like that we've done before? What does this look like that we've done before? It starts with a D. Roy? We just distribute the 3. Do you remember when we distribute to every term inside the parentheses? Same thing happens here, okay? We're distributing to every single term, every single exponent. Okay, we're going to stop here, put a line underneath your paper. This is where we're going to